Alright guys, so we're doing question number 13 from section 3.4. So, what does this one ask you to figure out? Well, it's asking you to recognize when to use the chain rule. So how do we know that we're going to use the chain rule? Pay attention to the brackets. It should be a giant red flag. Chain rule is going to be necessary when you see brackets and there's a variable in the brackets. So in our case, we have theta squared inside the brackets, so we know we're going to have to use the chain rule. So, the part inside the bracket is theta squared, and the part on the outside is basically cos some stuff. Right? Pretty simple. So let's take the derivative. I usually like to use the phrase the outside derived with the inside left alone multiplied by the derivative of the inside. So the outside is basically cos theta is equal to negative sine theta. Now, we do have to write squared here when we're doing the derivative, only because there was a squared in our original problem. So we have minus sine squared theta, which is a little bit different than what we did in the first section. And then we have multiplied by the inside, the derivative of the inside. So we're just telling ourselves here to take the derivative of theta squared. The derivative of theta squared, of course, is 2 theta. That's pretty simple. And then, of course, we can move that 2 theta to the front, and then we just get negative 2 theta times sine of theta squared. Yeah, that's it. This was a really quick, simple problem. All it's trying to do is make sure that you know when to use the chain rule. So, if you see brackets and there's a theta or an x or whatever your variable you're driving is on the inside, you're going to have to use a chain rule. That's what's the important thing to remember here.